mathematicians. Today we're going to talk about everybody's favorite subject, long division. We're going to start with some vocab, and then I'm going to show you two different models to do your division with. Okay, starting with our vocab. The dividend is the total amount that you're starting with. So you can see here I highlighted it in yellow. The dividend is 200. That means we're starting with 200 pieces. Sometimes it's a word problem and we know what they are. Sometimes it's just a problem like this and we're like, okay, just the number 200. The divisor is that 5. And depending on the type of word problem, it can mean two different things. It can mean how many groups to break up your 200, your dividend, into. So here's a picture of that. 200 broken up into 5 groups. Or depending on the context of usually a word problem, it could also mean how many are in each group. So make 200 into groups of 5. You can see in this option here that there are 5 in each of those groups. So whichever way you're thinking about it, the answer is still the same, because if we look here, we have 200 split into 5 groups. How much is in each group? If you count them up, it's 5, 10, 15, 20, 25, 30, 35, 40 in each group. If you look at it this way, we ask how many total groups did we make, and if you count them all up, there are 40 groups there. So whichever way you're thinking about it, how many groups or the size of the group, your answer is the same. And the answer in a division problem is a vocab word we really need to know. It's called the quotient. All right, so now that we've talked about vocab, let's get into some actual division. The standard algorithm is everybody's favorite way to do division, in that like division house. So there are actually 3 ways to show a division problem, and I'm going to model them right here for you. Oops, too high. Let's say 215. The way you just saw me do it was with the division symbol, 215 divided by 5. That's one way to write it, with our dividend, our divisor, and we have to figure out what's the quotient, what's the answer. You're also going to see it written like, 215 divided by 5. That's right, fraction bars are actually division problems. Think about it as one giant division problem. There's our division symbol. We've got a number up here, the 215, a number down where that other like circle in the division symbol is, the 5. This is a way that you will see division problems represented. But when we do the standard algorithm, we normally do this method, the house. The dividend, what you're starting with, goes inside. The divisor, how many groups or like make groups the size of, is going outside. And then we're going to write our answer up here in the quotient. The way this works is we break it up into the digits and we say, if I have 2, I'm going to model it over here. If I have 2, can I make a group of 5? No, that's not enough. So I'm really picky. I want you to write that 0 right here, because especially when we start talking about decimals or bigger numbers, we don't want to get messed up with our place value. So I want you to put a digit on top of each of the digits in 215, and sometimes that digit is just a 0 at the front. Now we're going to look at this 2 and the 1, 21. If I had 21 dots, oh gosh, let's try it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. How many groups of 5 can I make? I can make 1 group, 2 groups, 3 groups, 4 groups. Nope, no more than 4 groups. Now, you do not have to draw it out. I'm just a very visual learner, and that's kind of how I think about it. You can also run through your 5's times tables and say, I want to get really close to 21, but not go over it. 5 times 1 is 5. 5 times 2 is 10. 5 times 3 is 15. 5 times 4 is 20. 5 times 5 is 25. Oh, too big. Times 4. You can make 4 groups of 5. That means you've used up 20 of those dots, and you've got 1 left over. See that one sad one that wasn't in a group? Oh, so sad. Now we're going to bring down this 5. That really means we're just talking about this 1 is really a group of 10, and we're adding the 5 ones. Now if you had 15 dots, how many groups of 5 could you make? 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15. 3 groups of 5, use up all 15, and you have no remainder. We're going to talk about what to do with remainders if you get them later, but we're saying goodbye to that letter R. It's not going to be an R and then whatever that remainder is. We'll get there eventually. This is the way you do the standard algorithm. When you're writing your final answer, you can drop that 0 in the front and just say my answer is 43. Now, that is not everybody's cup of tea. So let me show you another strategy that maybe is better if you like the partial products way of multiplying. We can kind of use it as a backwards way to divide. I'm going to take that same problem and say, where is my little dot? There it is. 215 divided by 5. Now, if this was 215 times 5, you might break it up and say, okay, 5 is a 1-digit number and 215 has 3 digits, so break it up like this. 5 times 200 times 1 times 5. But this is not times. This is the opposite. The 215 is kind of like the answer. Remember in a fact family, our quotient times 5 should equal 215. So what we can actually do is work it backwards and say 5 times something is going to equal 200. 5 times something is going to equal 10. And 5 times something is going to equal 5. Now, huge alert, this strategy will not always work nice and simply, and you won't always get final answer that doesn't involve regrouping. So this strategy is not perfect. It's not going to work all the time, but it's a nice place to start, and maybe you can estimate your answer from there, and it will work most of the time. So let's think about what number times 5 equals 200. So you can kind of work your way back. I might even break it down and say, okay, what number times 5 equals 20? Because I know that times table. I know that 5 times 4 equals 20. And since I'm dealing with an extra 0 there, I think 5 times 40, yep, that should work. So get rid of my question mark. I'm now confident 5 times 40 equals 200. This one's a little easier. 5 times what number equals 10? 2. 5 times what number equals 5? 1. Add these all up, these partial quotients. 40 plus 2 plus 1 is 43, which is the same answer we got the other way. This is just a way to kind of break it down and decompose it. It's a strategy you might like. Again, it won't always work because sometimes you'll have like a remainder that needs to get regrouped. But if you really like this way and you want to talk about how to deal with regroupings in partial quotients, come find me and we can talk about it.